ሰላም ለእናንተ ይሁን። ዛሬ በዚህ ቪዲዮ ይዤላችሁ የቀረብኩት ወርክሺት 2 ማለትም ለቤዚክ ማትማቲክስ ፎር ሶሻል ሳይንስ ፋንክሽን ላይ ያሉ ጥያቄዎች የተካተቱበት ወርክሺት ሶሉሽን ይሆናል ማለት ነው። ስለዚህ እንደተለመደው በቀጥታ ወደ ጥያቄዎቹ ከመሄዳችን በፊት ምናልባት ለዚህ ቻናል አዲስ የሆናችሁ ልጆች አሁንም ሰብስክራይብ እና ይህንን ቪዲዮ ደግሞ ላይክ በማድረግ እንድትጀምሩ አበረታታለሁ። ጥያቄዎቹ ወርክሺቱ ይህን ይመስላል። ስለዚህ በርካታ ጥያቄዎች ናቸው። በአንድ ቪዲዮ የሚጠቃለሉ አይደሉም። ቢቻልም እንኳን ብዙ ሰዓት የሚወስድ ስለሚሆን በሁለት ፓርት መስራት ነው የፈለኩት። ስለዚህ ይህ ቪዲዮ የመጀመሪያው ፓርት ይሆናል ማለት ነው። ይህን ካልኩ በኋላ በቀጥታ ወደ ጥያቄዎቹ በምንሄድበት ጊዜ የመጀመሪያው ጥያቄ ኦን ኢኒኳሊቲ ላይ ይሆናል። ኢት ሴይዝ ሶልቭ ዘ ሊኒየር ኢኒኳሊቲ 3x minus 7 less than 2. Therefore, in order to solve such a linear inequality, we have to apply the usual methods that just simple simplification. So that, for example, if we add 7 to both sides of this inequality by using that of addition property, we have this one that is 3x less than 9. And if we divide both sides of this inequality by 3, we have this one that is x less than 3, because dividing both sides of the given inequality by a positive real number will not affect the inequality, and the sign of inequality must be kept as it is. And therefore, the solution set will be x less than 3 or 3 to that of negative infinity. Next question. Solve the linear inequality again, 5x plus 4 greater than or equal to 19. Again, in order to solve this inequality, using addition and product or simply quotient property. If we subtract 4 from both sides of this inequality, we have 5x plus 4 minus 4 is 5x, and 19 minus 4 is 15, so that we have 5x greater than or equal to 15. And if we divide both sides of this inequality by the coefficient of the variable that is x, just to make x alone, that means we have x greater than or equal to 3. Therefore, the solution set will be x greater than or equal to 3, or the closed interval that is including 3 from 3 to positive infinity. Next question. Again, it is on inequality 2 minus x over 3 greater than 5. Similarly, if we, for example, that is subtract 2 from both sides of this inequality, we have minus x over 3 greater than 3. And in order to make x alone here, let us multiply both sides of this inequality by the coefficient of the variable x, which is negative 1 over 3. Therefore, but multiplying both sides of this inequality by negative 3 will not, or simply must change the sign of inequality from greater than to less than sign, so that when we multiply both sides of this inequality by negative 3, we have x less than negative 9. Therefore, the solution set will be x less than 9, or an open interval from negative 9 to negative infinity. Next, 7x minus 2 less than or equal to 3x plus 10. Therefore, again, in order to solve this one, we have to collect the variables to the left side of the inequality and the real number to the right side, so that we can subtract, for example, that simple 3x to both sides of this inequality, just to bring this one to the left side, and we have to add to the both sides of this one, just to take minus to the right side. Therefore, we have, that is, if 3x is subtracted from both sides of this inequality, we have 7x minus 3x is 4x, and 3x minus 3x is 0, so that 4x minus 2 less than or equal to 10 will be obtained, or simply, there is an inequality which is obtained from this one by subtracting 3x from both sides. Then when we take again minus 2, or simply if we add 2 to both sides, we have 4x less than or equal to 12. And if we divide both sides by 4, we have x less than or equal to 3. So that the solution set for this inequality will be set of real number less than or equal to 3, or closed interval that is from positive 3 to negative infinity. So that this interval will be the solution set for this inequality. Next, it is an absolute value. Solve the linear inequality, that is the absolute value of 2x minus 5 less than 7. Therefore, the solution set could be, using the absolute property, we know that the absolute value of 2x minus 7 less than 7 means, that is the absolute value of 2x minus 5 less than 7 means, this one, that is 2x minus 5, must be in between negative 7 and positive 7. So that we have two inequality sign of inequalities here, and three terms are connected by using these two inequalities. Therefore, in order to find the value of the possible values of this one, that's a variable that is x, that can make this inequality to be true. If we add 5 throughout, that is simply with minus 7 to x minus 5, and this one, that's simply 7. That is just to make x alone here. We have minus 7 plus 5 is minus 2, 2x minus 5 plus 5 is 2x, and 7 plus 5 is 12. ስለዚህ እናገኘን እንደገና x ብቻውን እንዲቀርልን ሌታስ divide minus 2 2x and 12 by the coefficient of the variable x, which is 2. And therefore, when we do this, we have this one, that is minus 1 less than x less than 6. Therefore, the solution set could be the set of real number in between minus 1 and 6, or it is an open interval from minus 1 to positive 6. Therefore, this interval will be the solution set for this inequality, which is the absolute value of 2x minus 5 less than 7. Next, solve each of the following quadratic inequalities and represent the solution set on a real line. We have this one, that is the first one, x squared minus 5x plus 6 plus greater than 7, I mean 0. Next, 2x squared plus 4x minus 2 less than or equal to 0. C, x squared plus 4x plus 4 greater than or equal to 0. And lastly, we have minus x squared plus 6x minus 8 less than 0. So let us start from the first one. What we are given here is x squared minus 5x plus 6 greater than 0 is given, so that we are asked just to find the solution set of this quadratic inequality. ስለዚህ በቅድሙ የሚለየው ምንድነው? ቅድም ያየናቸው ምንድናቸው? they were linear inequalities። እዚህ ደግሞ ኳድራቲክ ወይም ደግሞ ዲግሪው ሁለት የሆነ ኳድራቲክ ኢኒኳሊቲ የተሰጠን ማለት ነው። ስለዚህ ይህንን ሶልቭ በምናደርግበት ጊዜ ለምሳሌ ፋክቶራይዜሽን ሜተድ ልንጠቀም እንችላለን፣ ሳይድ ቻርት ሜተድ መጠቀም እንችላለን። ለምሳሌ factorization method, if we factorize this one, that is, we need to find two real numbers whose sum is negative 5 and whose product is positive 6. And these two real numbers are minus 2 and minus 3, so that this one, that is x squared minus 5x plus 6, can be expressed as the product of x minus 2 and x minus 3. So that is fully the factorized form of this quadratic term. Therefore, it must be greater. አሁን እዚህ ጋር ይሄንን በዚህ መልኩ ፋክተራይዝ ካደረግን በኋላ የነዚህ ሁለት ሊኒየር ፋክተሮች ፕሮዳክት ፖዚቲቭ ሊሆን የሚችለው መቼ ነው ብለን ስናስብ ሁለት ኬዞች አሉን። የመጀመሪያው ሁለቱም ሊኒየር ፋክተሮች ፖዚቲቭ በሚሆኑበት ኢንተርቫል ላይ ወይም ደግሞ ሁለቱም ፖዚቲቭ ናቸው ብለን ስናስብ ነው። ሁለተኛው ደግሞ ሁለቱም x minus 2 እና x minus 3 እነዚህ ሁለት ሊኒየር ፋክተሮች በተመሳሳይ ጊዜ ኔጌቲቭ በሚሆኑበት ጊዜ ነው። ስለዚህ የዚህ ሶሉሽን ሴት ምን ይሆናል ማለት ነው? በሁለቱም ኬዝ የምናገኛቸው ሴት ኦፍ ሪል ነምበርስ ዩኒየን ይሆናል ማለት ነው። ስለዚህ the product is positive when both factors have the same sign. That is either the first case, that simply both x minus 2 and x minus 3 positive በሚሆኑበት ጊዜ ነው። ስለዚህ እነዚህ ፖዚቲቭ የሚሆኑት መቼ ነው? when x is greater than 0 and x is greater than ግሬተር ዛን 3 ስለዚህ የነዚህ ኤንድ ነው። ሁለቱም በተመሳሳይ ጊዜ ነው መሟላት ያለባቸው። ስለዚህ የነዚህ ሁለቱ ኢንተርቫሎች ኢንተርሴክሽን ማለት that is the intersection of x greater than 2 and x greater than 3 will be x greater than 3, so that x greater than 3 could be half of the solution set for this quadratic inequality. The other possibility where the product of these two linears to be positive is that both x minus 2 and x minus 3 needs to be negative. That means x minus 2 less than 0 and x minus 3 less than 0. ስለዚህ እነዚህ ሁለት ሊኒየር ፋክተሮች ኔጌቲቭ የሚሆኑት x minus 2 ኔጌቲቭ የሚሆነው when x is negative 2, I mean x is less than 2, and x minus 3 will becomes negative when x is less than 3. ስለዚህ end ነው ይሄ ኢንተርሴክሽን ነው. So that the intersection of these two intervals will be the smallest intervals, that is x minus 2. ስለዚህ የዚህ ሊኒየር ኳድራቲክ ኢኒኳሊቲ ሶሉሽን ማለት በእነዚህ ሁለት ኬዞች ላይ የተገኘ ሶሉሽን ዩኒየን ይሆናል ማለት። ምክንያቱም እነዚህ የተያያዙበት ይሄ ኦር ነው። ኦር ስታንድስ ፎር ዩኒየን ዴርፎር the union of x less than 2 union x greater than 3 could be the solution set for this inequality. Therefore the solution set is this one. ስለዚህ within this interval if you take any real number so that this quadratic inequality will be satisfied. B 2x square plus 3x minus 2 less than or equal to 0 is given. Therefore, in order to solve this quadratic inequality, again using data factorization, hopefully this quadratic term can be expressed as or simply as the product of these two linear factors. And the product of these two linear factors, ቅድም የተጠቀምነውን ኳድራቲክ ወይም ደግሞ ፋክቶራይዜሽንም ደግሞ ፕሮፐርቲውን አፕላይ ማድረግ እንችላለን፣ ወይም ደግሞ ምን ማድረግ እንችላለን? ይሄ ሳይን ቻርት ሜተድ መጠቀም እንችላለን። ስለዚህ ሳይን ቻርት ሜተድ ለመጠቀም መጀመሪያ we need to find the critical points. Critical points means they are points or simply the values of the variable that can make the quadratic equation to be zero. The zero of the quadratic equation, that means the equation which is obtained from the inequality by substituting or replacing the sign of inequality by simply equality. ስለዚህ ይህን ወደ ኢኩዌዥን ከቀየርን በኋላ የኳድራቲክ ኢኩዌዥኑ ዜሮዎች ማለት የዚህ የኢኒኳሊቲ ክሪቲካል ፖይንቶች መሆናል ናቸው ማለት ነው። ሌላው እነዚህ ሁለት ክሪቲካል ፖይንቶች ምንድነው የሚያደርጉት? ሁለት ክሪቲካል ፖይንቶችን ዲስቲንክት ካገኘው ለምሳሌ አንዱ ሴት ኦፍ ሪል ነምበር ወይም ደግሞ ሴት ኦፍ ሪል ነምበር ወይም ደግሞ ሪል ላይኑ ለሶስት ነን ኦቨርላፒንግ ኢንተርቫሎች ይከፈላል። ስለዚህ የዚህ ኳድራቲክ ኢኒኳሊቲ ሶሉሽን ሴት ማለት እዚህ በእነዚህ ክሪቲካል ፖይንቶች በተከፈሉ ሶስት ነን ኦቨርላፒንግ ኢንተርቫሎች ወይ ሁለቱ ሊሆኑ ይችላሉ ወይ አንዱ ብቻ ሊሆን ይችላል። ስለዚህ እሱን እንዴት ነው የምንለየው? ወይም ደግሞ እሱን ለመለየት we can apply or simply use the application of sign chart method. ስለዚህ የመጀመሪያው ኢንተርቫል that is x is equal to መጀመሪያው critical point that simply -2 from -2 that of negative infinity. The second one is from negative in between -2 and positive 1 over 2, and the last one, the third one is said to be from 1 over 2 to that positive infinity. ስለዚህ እነዚህ ሶስቱም ነን ኦቨርላፒንግ ኢንተርቫሎች ናቸው። ስለሆነም የዚህ ኳድራቲክ ኢኒኳሊቲ ማለት ከእነዚህ ሶስት ኢንተርቫሎች ወይ የመጀመሪያው ሊሆን ይችላል፣ ሁለተኛው ሊሆን ይችላል፣ ሶስተኛው ሊሆን ይችላል። ከእነዚህ ከሶስቱ የትኞቹም ሁለት ሊሆን ይችላል ማለት ነው። ስለዚህ እንዴት ነው ምንድነው የምናደርገው? የመጀመሪያው ለምሳሌ የመጀመሪያው ሊኒየር ፋክተር የዚህ ኳድራቲክ ኢኒኳሊቲ ኤክስ ፕላስ 2 ነው። ስለዚህ ይሄ ኤክስ ፕላስ 2 በእነዚህ በሶስቱ ኢንተርቫሎች ላይ ያለው ሳይን ምን ይመስላል የሚለውን እንወስዳለን። ለምሳሌ from negative to negative infinity x plus 2 is negative. ለምሳሌ just as a testing point or simply checking point, -3 is within this interval. If we substitute -3 for x here, it is negative, so that x plus 2 is always negative within this interval. And we in between -2 and that of positive 1 over 2, that means if we take the value for x which is greater than -2 and less than positive, ለምሳሌ 0 በምንወስድበት ጊዜ If you substitute 0 here, x plus 2 will becomes positive. Similarly, the same term, the factor that simply x plus 2 within this interval that is 1 over 2 to positive infinity is positive. Similarly, the second linear factor that is 2x minus 1 could be within the first interval is negative, positive. ከዛ በኋላ እነዚህ ሁለት ሊኒየር ፋክተሮች ኔጌቲቭ ሆኑ ማለት ስለዚህ እነዚህ ይሄ ምንድነው የሚሆነው የዚህ ፕሮዳክት ማለት ኔጌቲቭ ወይም ደግሞ ዜሮ የሚሆንበት ኢንተርቫል ላይ የተፈለገው ስለዚህ የነዚህ ሁለት ሊኒየር ፋክተሮች ፕሮዳክት ይሄንን ኳድራቲክ ኢኒኳሊቲ ይሰጠናል ስለዚህ የዚህ ኳድራቲክ ኢኒኳሊቲ ሳይን ምን ይሆናል ሲባል የነዚህ ሁለት ሊኒየር ፋክተሮች ሳይን ፕሮዳክት ይሰጠናል ማለት ነው እዚህ ጋር within minus negative infinity ሁለቱም ኔጌቲቭ ናቸው so that negative times negative will be positive similarly within the interval from minus to positive 1 over 2 both and the first x plus 2 is negative positive but 2x minus 1 is negative so that positive times negative ይሄ ፕሮዳክት ኔጌቲቭ ይሆናል ማለት ነው ሌላ እዚህ the last one from 1 over 2 to positive infinity ሁለቱም ፖዚቲቭ ናቸው so that positive times positive is positive አሁን ይሄንን ሳይን ቻርቱን በዚህ መልኩ ካዘጋጀን በኋላ የሚቀጥለው ስራችን ምንድነው የሚሆነው ወደ ኦሪጂናል ኢኒኳሊቲያችን እንመለሳለን ኢኒኳሊቲያችን ምንድነው የሚሆነው የሚለው ፖዚቲቭ የሚሆንበትን ነው ወይስ ኔጌቲቭ ወይም ደግሞ ኔጌቲቭ እና ዜሮ የሚሆንበትን ነው ወይስ የትኛውን ነው የተጠየቅነው የሚለው እናያለን ስለዚህ ጋር ይሄ ኳድራቲክ ተርም ኤክስፕሬሽን ኔጌቲቭ ወይም ደግሞ ዜሮ የሚሆንበት ኢንተርቫል ነው የተጠየቅነው ስለዚህ ለምሳሌ እዚህ ጋር x minus 2 በሚሆንበት ጊዜ exactly minus ሲሆን እዚህ ጋር 0 ይሆናል ይሄኛው ፖዚቲቭ ኔጌቲቭ ነው እዚህ ጋር x 0 x ኔጌቲቭ 1 over 2 ሲሆን 0 ይሆናል እዚህ ጋር 1 over 2 ሲሆን 0 ይሆናል ስለዚህ ኔጌቲቭ ይሄ ኢንተርቫል ወይም ደግሞ ይሄ ማለት ኔጌቲቭ የሚሆንበት ሳይን ቻርት ወይም ደግሞ from this chart ይሄ ኢንተርቫል from negative 1 over 2 to positive 1 over 2 ነው ማለት ነው ስለዚህ negative 1 over 2 እና positive 1 over 2 ኔጌቲቭ የሚሆንበት ነው ነገር ግን ምንም ይጠቃለላል ዜሮ የሚሆንበትም ይጠቃለላል ስለዚህ -2 x plus 2 0 ስለሚያደርግ 0 times this one will become 0 1 over 2 2x minus 1 0 ስለሚያደርግ ይሄ x plus 2 ከ0 የተለየም እንኳን ቢሆን ይሄ 0 ከሆነ 0 times an expression is 0 so that 0 less than or equal to 0 it becomes 0 so will be satisfied ስለዚህ the solution set could be a closed interval from negative 2 to positive 1 over 2 ይሆናል ማለት ነው therefore they hit the solution set question number C x squared plus 4x plus 4 greater than or equal to 0 is given. Therefore, the solution set of this quadratic inequality will be, I think it is perfect trinomial. This one is perfect trinomial, which is x squared plus 4x plus 4. So when the factorized form of this expression could be x plus 2, the whole square, which is greater than or equal to 0. ስለዚህ ብዙ justification አያስፈልገውም. The square of every real number is positive or simply it becomes 0 whenever x is exactly equal with that of -2 and therefore 0 since a square is always non-negative so that it is either positive or simply 0 so that the solution set of this inequality will be a set of real numbers so that any real number can satisfy this quadratic inequality. D minus x squared plus 6x minus 8 is negative. Therefore, again, if we multiply this point by -1, just to make the leading coefficient of this to be positive, so that we have the inequality that is x squared minus 6x plus 8 greater than 0. It was less than because if a given inequality is multiplied or divided by a negative number, the sign of inequality must be reversed or simply changed. And then The factorized form of this inequality could be x minus 2 and x minus 4, so that this product will become positive if either both these two linear factors are positive or negatives. ስለዚህ ይህ ፕሮፐርቲን አፕላይ በምናደርግበት ጊዜ the solution set could be x less than 2 union, that means simply or stands for union x greater than 4. Therefore ከዚህ ኢንተርቫል ወይም ደግሞ ከዚህ ማንኛውንም ሪል ነምበር ወስደን ለኤክስ ሰብስቲት ብናደርግ this inequality will be satisfied. Okay, I think already in its factorized form. Therefore, this could be positive. Again, or simply the critical points are x equal to 1 and x equal to negative 2. That is the zero of the linear factors of the given polynomial, quadratic inequality. And therefore, the product is positive outside the interval. Outside the interval means when x less than minus 2 or x greater than positive 1. X greater than positive 1. We can apply the property that already we applied just around the first quadratic inequality. Okay, question number 3. Consider sets A and B with their corresponding elements. Then after we are given this to set it, the question that follows from this one could be, we are asked just to list all the elements in A cross B, list all relations R from A to B, and lastly list all functions F from A to B. So let us see the first one. We know that the cross product of any two sets A cross B could be, it is the set containing in the form of that of A over B, where the first entry selected from the elements of the first set and the second entry for each element or simple order pair must be selected from the elements of the second set, that is set B in this case. Okay, ስለዚህ A እና B ምንድን ነው ያላቸው? ወይም ደግሞ the elements of A are 1 and 2 and the elements of B are S and T, so that one can be combined with both the elements of B, that is S and T, so that we can have 1S, 1T, and 2S and 2T. Therefore, we have 1S, 1T, 2S, and 2T could be the cross product of the two sets, that is A and B. And ሌላው እዚህ ጋር ማስታወስ የሚገባን ነገር ምንድን ነው? number of elements of A cross B ከnumber of elements of A and B ጋር ሪሌሽን አለው። ስለዚህ ያ ማለት A እና B ሁለቱ ፋናይት ሴት ከሆኑ that means if they do have fixed number of elements, ስለዚህ የA cross B number of elemenቶች number of element of A times number of elements of B ነው። ስለዚህ እዚህ ሁለት አለ፣ ይሄም ሁለት አለ። ስለዚህ the number of elements of A cross B must be 2 times 2, that is 4, so that we have 4 elements here. Similarly, a relation is any subset of A cross B. That means the second or simply the question could be, we are asked just to list all relations are from A to B. relation form እንድናደርግ ወይም ደግሞ ይሄ ሊስት እንድናደርግ ነው። ስለዚህ a relation is any subset of cross product of these two sets, or simply cross product already እዚህ ጋር ተሰጥቶናል። ስለዚህ ለዚህ subset የሆነ any set could be that can be considered as a relation R from A into B. ለምሳሌ we know that empty set is the subset of any set. ስለዚህ አንዱ ማን ሊሆን ይችላል? empty set ሊሆን ይችላል። ይችን ኤሌመንት ብቻ the relation containing only 1 and S or 1 and T, 2 and S, either of this one or the combination of 2 or the combination of 3 or the set itself, that is across B, could be the relation which is defined from A into B. ስለዚህ we can have this example that simply set empty sets. Since empty set is the subset of any set, the set containing only the first element, that is 1S, the set containing 1S and 2T, the set containing 1S, 1T and 2S, or the set containing 1T and 2S. ስለዚህ ብዙ ነው ማግኘት የምንችለው። ራሱ A cross B እዚህ ጋር ኢንክሉድ ይደረጋል። ስለዚህ በዚህ መልኩ ማግኘት እንችላለን ማለት ነው። with respect to that of the number of elements of this one, እንግዲህ ኤ ክሮስ ቢ ወይም ደግሞ ይሄ ሪሌሽን አር ፍሮም ኤን ቱ ቢ ማለት ለዚህ ለኤ ክሮስ ቢ ኤኒ ሳብሴት ከሆነ we know that the maximum or simply the number of subsets of any finite set could be to the power of the number of elements of the given set. We have the number of elements of A cross B is 4, so that to the power of 4 could be 16 relations can be constructed based on the given set is A and B. Next one, that is C. A function assigns exactly one element of B to each element of A. That means first C says list all functions f from A to B. Therefore, we have this one. Therefore, the functions are f1, for example. ስለዚህ አንድ function from A to B ከሆነ ምን ማለት ነው? የመጀመሪያው ዶሜኑ A መሆን አለበት. And the range of the given function must be the subset of its codomain, that is simply B. ስለዚህ ይሄ አንዱ function ነው, because each and every first entry is paired with exactly one element within its range. ስለዚህ የዚህ ዶሜን ለምሳሌ 1 and 2, which is exactly A, and second could be 1s and 2d. Again, the domain is the same, that's simply the set A itself. 1 and 2d and 2s, and lastly we have 1 and 2d. ከነዚህ ከአራት ውጭ ሌላ የለንም። ስለዚህ based on the elements of set A there, the possible function that can be constructed could be only these four functions. Okay, question number 4. Let A is equal to the set containing W, X, Y, and Z, and B is equal to 3, 4, 5. Then each of the following sets of is a relation from A to B. Determine which ones are functions. So what we are given here is this one, B, C, and D. ስለዚህ ከነዚህ ፋንክሽን የሆነ ነው የምናወጣው ወይም ደግሞ የምንመርጠው ማለት እነዚህ ሪሌሽኖች ናቸው በሙሉ because all this one that simply are the subset of A cross B. ስለዚህ ከነዚህ ሪሌሽኖች ውስጥ ፋንክሽን ሊሆን የሚችለውን ማግኘት ወይም ደግሞ ሴሌክት ማድረግ ነው። ስለዚህ አንድ ሪሌሽን ፋንክሽን የሚሆነው መቼ ነው ስንባል ወይም ደግሞ ሲባል ምን ማለት ነው? የመጀመሪያው the function is defined from A to B already or simply without anything. The domain of the given function must be A. A መሆን አለበት፣ ዶሜኑ ይሄ መሆን አለበት። ስለዚህ ለምሳሌ እዚህ ጋር w3 x4 y5 ይላል። ማን የለም? አሁን እዚህ ጋር z የለም። ስለዚህ ይሄ ሪሌሽን ፋንክሽን ሊሆን አይችልም ማለት ነው። ፋንክሽን ነው፣ ነገር ግን ይሄ ፋንክሽን it is not a function from A to B because the domain is different from that of A. አርን በምንወስድበት ሁለተኛውን ቢንስ በምንወስድበት ጊዜ we have w3 x4 y5 z5 w x y z ዶሜኑ ይሄም እንኳን ቢሆን ነገር ግን ይሄ ፋንክሽን አይደለም። ምክንያቱም y is the image of this one, that's simply y. Sorry. Okay, they hit the function clearly. It is a function. That means the domain is the set containing w, x, y, and z, which is exactly A. So that each and every element of the domain is paired with exactly one element within its range. Therefore, B is a function. ይሄኛውን እዚህ ጋር ስንመጣ we have w3, x3, y3, z3, which is a constant function. W, x, y, z is the domain, so that is a constant function. Therefore, this relation is a function. And lastly, that's simply D, w3, x5, y4, z3, and z4. W, x, y, z, the domain is the same, that's simply A, but ይሄ ፋንክሽን አይደለም። ምክንያቱም one of the first, the last component of this one that simply that has two different images which are 3 and 4. ስለዚህ የፋንክሽን ፕሮፐርቲ አይደለም due to the existence of these two elements. Therefore, this is not a function. ስለዚህ ኤ እና ዲ ፋንክሽኖች አይደሉም፣ ቢ እና ሲ ግን ፋንክሽኖች ናቸው። if you need the justification, a relation is a function if every element of the domain has exactly one image. And therefore, A is not a function because Z has no image. ያ ማለት ዶሜኑ አልሆነም ማለት ነው። B functional because each element of A has exactly one image. B is also a function because each element has exactly one image again. But D is not a function because Z has two images 3 and 4, which are different. Therefore, this is the solution. Okay, next. Determine if the following relations are functions. Then state the domain and their range. ስለዚህ ሁለት ጥያቄ ነው የተጠየቅነው። መጀመሪያ የተሰጠን ሪሌሽን ፋንክሽን ነው ወይስ አይደለም የሚለውን ጀስቲፋይ እናደርጋለን። ከዛ ቀጥሎ ደግሞ የተሰጠንን ሪሌሽን ወይም ደግሞ ፋንክሽን ከሆነ ዶሜን እና ሬንጁን ስቴት እናደርጋለን ማለት ነው። ስለዚህ የመጀመሪያው ለምሳሌ ሴት ኤ 1 1 2 2 3 4 and 4 5 I think it is a function ምክንያቱም ሁሉም የመጀመሪያዎቹ ኤንትሪ ወይም ደግሞ ዶሜኑ ኤለመንት አንዳንድ ኢሜጅ ብቻ ነው ያላቸው። ስለዚህ ዶሜኑ ማን ይሆናል ሲባል the set containing all the first entries of each element so that 1 2 3 and 4 could be the elements of this function. ሁለተኛው ቢ 1 5 5 1 5 2 2 5 ይሄ ፋንክሽን አይደለም because of the existence of these two elements 5 1 and 5 2 which are 1 and 2 are different therefore ይህ ፋንክሽን አይደለም but ዶሜኑ ምን ይሆናል አንድ አምስት እና ሁለት ዶሜኑ ሲሆን the range is 5 1 2 5 1 2 C this one that is 1 negative 2 negative 2 0 minus 1 2 and 1 3 ይህም ፋንክሽን አይደለም ምክንያቱም እዚህ ጋር the image of 1 is minus 2 again the image of 1 is 3 minus 2 is different from that of 3 so that due to the existence of these two elements this relation cannot satisfy the condition to be a function. And the last three that is minus 3 2 minus 3 is 3 3 minus 5 5 2 ይህም ፋንክሽን አይደለም ምክንያቱም minus 3 the image of minus 3 here is 2 and it has also another image that simply 3 and 2 is different from that of 3 so that በእነዚህ ሁለት ምክንያቶች ወይም ደግሞ ምክንያቱም የዶሜኑ አንዱ ኤለመንት ማይነስ 3 ከአንድ በላይ ኢሜጅ አላት 2 እና 3 ስለዚህ ይሄ ፋንክሽን ወይም ደግሞ ይሄ ሪሌሽን ፋንክሽን አይደለም ማለት ነው። when we justify this one በመጀመሪያው ለምሳሌ ይሄን ይመስላል ስለዚህ ፋንክሽን ነው the domain of this one is 1 2 3 and 4 and its range would be 1 2 4 5 1 to 4 5 Similarly, the second one that simply be ይሄ ምን አይደለም ይሄ ፋንክሽን አይደለም since 5 maps to both 1 and 2 5 1 5 2 that means then the given set is not a function ባይሆንም በሪሌሽኑ ዶሜን ምን ይሆናል ሲባል the domain is 1 5 2 or 1 to 5 and the range could be 5 5 1 2 or simply 1 to 5 again 1 to 5 again so that his dominant range of this relation which is not a function. The next one that is C we have this one therefore አሁንም ይሄ ምን አይደለም ፋንክሽን አይደለም ብለናል ምክንያቱም one has two images which are minus 2 and positive 3 therefore it is not a function anyways the domain is simply 1 negative 2 minus 1 minus 2 minus 1 1 minus 2 minus 1 1 and the range could be the range is minus 2 0 to 1 or in arranged form minus to 0 to 3 could be the range of this relation. Next or simply the last one we have this one ይሄንን ምን አይደለም ብለናል ፋንክሽን አይደለም ምክንያቱም minus 3 ሁለት ኢሜጅ ነው ያለው 2 እና ፖዚቲቭ 3 which are different ስለዚህ ፋንክሽን አይደለም ባይሆንም ግን ዶሜን እና ሬንጅ ምን ይሆናል ሲባል the domain is minus 3 positive 3 and 5 that is the domain is minus 3 positive 3 and 5 and the range could be positive 2 3 negative 5 and positive 2 again that means minus 5 positive to 3 minus 5 positive to 3 Okay. Question number 6. I did the question on compulsion function. Compulsion function. That means SOR or and ROS are composed of S እንድንፈልግ ነው የተጠየቅነው። The first one that is A, this one, R and S are given, B, this one. ስለዚህ እነዚህ ሁለት ጥያቄዎች ኮምፖዚሽን ፈንክሽን አስ ኮምፖዝድ ኦፍ አር እና አር ኮምፖዝድ ኦፍ ኤስ ምን ይመስላል ደግሞ እንዴት ይገኛል የሚለው ነው የምናየው ማለት ነው። ስለዚህ ከመጀመሪያው ስንነሳ we have R in this one containing two order pairs, S has also two order pairs. ስለዚህ ምንድን የጠየቅነው እዚህ ጋር by definition first S composed of R means if in the set containing an element of this one that is xz, so that this xz could be an element of this one is composed of R if there is y containing the order pair that is xy which is an element of R and yz is an element of z. ስለዚህ S composed of R ማለት እዚህ R ላይ ኤክስ ዋይ የሚባል ኤክስን ከዋይ ጋር ማፕ የሚያደርግና እንደገና ደግሞ ኤስ ዋይን ተቀብሎ ከዜድ ጋር ማፕ የሚያደርግ ከሆነ so that xz could be one of the possible elements of S composed of R. በነገራችን ላይ ይሄ ብራስ እዚህ ነበር መዘጋት የነበረበት። ይሄ ብራስ እዚህ እንዳለ አስቡት። ስለዚህ አንዱ ይሄ ነው። ሁለተኛው ደግሞ in component wise S composed of R of x means S of R of x ያ ማለት መጀመሪያ ይሄ R xን ወደ ሆነ ቦታ ይወስደዋል። ከዛ ደግሞ from the image of this one that is x under R so that we can find the image of this one that is simply the image under S. ስለዚህ S composed of Rን በምንፈልግበት ጊዜ S composed of Rን በምንፈልግበት ጊዜ we can start from the inner function here is R because R maps positive 2 to 3 and S maps to that of 3 and 4 so that S composed of R could be this one that is simply to 3 and to 4. ያው እንዴት ነው የሚገኘው ተመልከቱ እዚህ ጋር R the image of 2 under R could be the image of 2 under R is 3 ስለዚህ ይሄ 3 the image of 2 under R could be this one that simply 2 is mapped to 2 and then again the image of 2 under S could be 3 so that 2 3 could be the element of S composed of R. Similarly within R the image of this one that simply 2 under R is 2 and the image of 2 under S is also 4 so that 4 could be an element of S composed of R. Then when we interchange the position of S and R, that is R composed of, also because output of S are not inputs in R, we have R composed of S is empty set. ምክንያቱም ለምሳሌ ከዚህ ከኤስ ላይ ስንነሳ the image of 2 under S is 3 but 3 doesn't have an image under R, or the image of 2 under S is 4, 4 doesn't have any image, so that R composed of S is empty set. Next B, R is this one and S is given here. ስለዚህ S composed of R ምን ይሆናል? Let us start from R. We know that the image of 1 under R is 2 and the image of 2 under S could be 3 so that 1 3 must be an element of S composed of R. Similarly again the image of 1 under S under R is 3 and the image of 3 under S is 5 so that 1 5 must be an element of S composed of R, 1 5 here. And the other could be the image of this one that's simply 1 under R is 2 and the image of 2 here is again 4 so that 1 4 must be an element of S composed of R. And lastly the image of 5 under R is 7 and the image of 7 under S is 1 so that 5 1 must be an element of S composed of R. Therefore S composed of R could be this with this element that's simply 1 3 1 4 1 5 and 5 1. Similarly, R composite of S could be this one. That means ለምሳሌ እዚህ ጋር የሁለት ኢሜጅ አንደር ኤስ ሶስት ነው። ሶስት ግን እዚህ ኢሜጅ የለውም። ስለዚህ two cannot be an element of or simply cannot be found within the domain of R composite of S. ኦኬ ሁለትም እዚህ ጋር የለም። ሶሪ የለም to four እዚህ የለም ኢሜጅ የለውም። therefore we cannot include two within as the element of the domain of R composite of S. እዚህ ጋር ስንመጣ the image of 3 under S is 5 and the image of 5 under R is 7, so that 3, 7 could be one of the possible elements of R composite of S. ኦኬ ስለዚህ አንዱ ኤሌመንት ይሆናል። ሁለተኛው the image of 7 under S is 1 and the image of 1 under R could be 2, so that 7, 2 is an element of R composite of S. And also the image of 1 under R is this one, that's simply 3, so that 7, 3 could be an element of this R composite of S. ስለዚህ የR composite of S ኤሌመንቶች set containing 3, 7, 7, 2 and 7, 3 ይሆናሉ ማለት ነው። Okay, next using that formula በሚሰጠን ጊዜ let f of x is 2x square minus 3 and g of x is x plus 1. ስለዚህ ይሄ ኦኬ ኦፕሬሽን ኦን ፋንክሽን የተጠየቅ ነው። መጀመሪያ የምንተጠየቅን እዚህ ጋር f plus g of 2 f times g of negative 2 g over f of 3 f plus g of x f times g of x g over f of x fog ጎፍ ፎግ and ጎፍ again። ስለዚህ እነዚህ እናያለን ማለት ነው። አሁን ሁለት ነው ኦፕሬሽን እና ኮምፖዚሽን using that formula። ኦኬ የመጀመሪያው ለምሳሌ f of x is equal to 2x square minus 3 g of x is x plus 1 is given። ስለዚህ ከዚህ ከተሰጠን በኋላ ምንድነው የተጠየቅነው? f plus g of 2. We know that by definition f plus g of 2 ማለት f of 2 plus g of 2 ነው. But f of 2 is, if we substitute 2 in the place of x here, it becomes 2 times 2 square. That is 2 times 4, which is 8. 8 minus 3 could be 5. And g of 2 could be, if we substitute 2 in the place of x here, 2 plus 1, that's simply 3. Therefore, f plus g of 2 could be 5 plus 3, which is 8. Similarly, f times g of minus 2 could be f of minus 2 times g of minus 2. But f of minus 2 could be minus 2 square is 4. 4 times this one, that's simply 4 times 2 is 8. 8 minus 3 could be 5. And g of minus 2 would be minus 2 plus 1, that's minus 1. Therefore, this is minus 5. Therefore, f times g of minus 2 is minus 5. And lastly, g over f of 3 could be, g of 3 over f of 3. G of 3 over 3 is equal to sign መኖር አለበት እዚህ ጋር g of 3 ማለት we have, if you substitute 3 here, we can have 3 plus 1, that's simply 4. And f of 3 could be, this f of 3 means 3 square is 9. 9 times 2 is 18. 18 minus 3 could be 15. So that 4 over 5 would be the image of 3 under g over f. Under g over f. Okay. Next. That is when f of x equal to 2x cubed, 2x square minus 3 and g of x x plus 1, the same function. ነገር ግን የተጠየቅነው ወይም ደግሞ የምንሰራው እዚህ ጋር ኦፕሬሽኑና ኮምፖዚሽኑ ይለያያል። Then f plus g of x, using that formula, we know that f plus g of x is simply the same as f of x plus g of x. And if we substitute the terms of f of x and g of x in the place of the functions here, we can have 2x square minus 3x, that is f of x, and plus x plus 1, which is g of x. So that this could be 2x squared plus x minus 2, I think. 2x squared minus x minus 2 could be the formula for f plus g of x whenever f of x is 2x squared minus 3 and g of x is x plus 1. Next, f times g of x. f times g of x is simply by definition, it is f of x times g of x. ስለዚህ እነዚህን ተርሞችን f of x ላይ እና g of x ላይ ስንተካ we have 2x squared minus 3 times x plus 1 and the product of these two binomials could be this one that is 2x cubed plus 2x squared minus 3x minus 3 ይህን ማባዛት ነው በቀጥታ። Next, g over f of x is equal to, that is g of x over f of x. Therefore, using simple substitution, we have x plus 1 over 2x squared minus 3. And next one, that is f composite of g of 2. F composite of g of 2, by definition, it is f of g of 2. But what is g of 2 here is? G of 2 is 3, so that's f of g of 2 is equal to f of 3, but f of 3 is this one, that's 15. And the last one, g composite of f of radical 2, is by definition, it is g of f of 2, but f of radical 2, I mean. But f of radical 2 could be, if you substitute radical 2 in the place of x within f of x here, the square of radical 2 is 2, 2 times 2 is 4, 4 minus 3 could be 1, so that is g of 1, but g of 1 is 1 plus 1, which is 2. Therefore, g composite of f of radical 2 is exactly equal with this one, which is 2. Next question, f of x given to be, and this one that's 2x squared minus 3 again, and g of x, x plus 1, then we are asked just to find f composite of g. F composite of g of x is equal to f of g of x, which is f of x plus 1, because g of x is x plus 1. ስለዚህ የዚህ ፋንክሽን ወይም ደግሞ ጌን ካገኘን በኋላ ወደ f of x በምንመጣበት ጊዜ if the image of this input that simply x under f is 2x squared minus 3, so what would be the image of x plus 1? ስለዚህ f of x ምንድነው የሚያደርገው? የተሰጠውን ስኩዌር ያደርጋል፣ ከዛ በሁለት ያባዛል፣ ከዛ በሶስት ይቀንሳል። ስለዚህ አውትፑቱ ይሄ ነው። ኢንፑቱ x ሲሆን 2x squared minus 3 is the output. ስለዚህ ኢንፑቱ x plus 1 ቢሆን ምን ይሆናል ነው። ስለዚህ ምንድነው የሚሆነው? I think it is just 2 into x plus 1 square minus 3. That is 2 into x plus 1 square minus 3, because this one is g of x. So that the simplified form of this one could be 2x squared plus 4x minus 1. Therefore, f composite of g of x, whenever f of x is this one and g of x is this one, could be 2x squared plus 4x minus 1. Next, g composite of f of x could be g of 2x squared minus 3, which is equal to 2x squared minus 3 plus 1. ምክንያቱም g of x ምንድነው የሚያደርገው? የተሰጠው ኢንፑት ላይ አንድ ጨምሮ ነው አውትፑቱን የሚያወጣው፣ ወይም ደግሞ አውትፑቱ ከኢንፑቱ አንድ መጨመር ነው። ስለዚህ ኢንፑታችን 2x squared minus 3 ቢሆን ምንድነው የሚሆነው? አውትፑቱ 2x squared minus 3 plus 1 ይሆናል። 2x squared minus 3 plus 1 ደግሞ 2x squared minus 2 ይሆናል ማለት ነው። So that g composite of f of x equal to 2x squared minus 2 ይሆናል። Next question, question number 8. For the functions g of x equal to the square root of x minus 1 and h of x equal to x squared plus 1, we are asked just to find the domain of g composite of h of x. ስለዚህ ይህንን የዚህን ዶሜን g composite of h of x ዶሜንን ለመፈለግ ምንድነው የምናደርገው? መጀመሪያ we need to find the expression for this composition function. ስለዚህ g composite of h of x equal to g of h of x, but h of x in this case is x squared plus 1, so that this is equivalent with g of x squared plus 1. ስለዚህ g of x squared plus 1, but the output of this x under g could be, it is just the square root of the input minus 1, so that the head equivalent with the square root of x squared plus 1 minus 1, which is equal to the square root of x squared. Therefore, this is g composite of h of x. ስለዚህ g composite of h of x ይሄ ከሆነ የዚህ ዶሜኑ ማን ይሆናል ሲባል this is always positive, so that this is always defined for any real number, so that set of real number could be the domain for g composite of h of x. Since x squared is greater than or equal to 0 for all real numbers, so that the set of real number could be can be considered as the domain of the given function. Question number 9. Which of the following functions are one-to-one function and on-to? ደግሞ ስለ one-to-one እና on-to function ስለዚህ የተሰጡን ፋንክሽኖች አሉ። ስለዚህ ከነዚህ ውስጥ one-to-one የትኛው ነው፣ on-to የትኛው ነው፣ ወይም ደግሞ one-to-one correspondence ወይም ሁለቱንም የሚያሟላ የትኛው ነው የሚለውን ማየት እንሞክራለን ማለት ነው። ስለዚህ ለመጀመሪያው ስንነሳ we are given this point that is f of x equal to 6x minus 1. ስለዚህ ፋንክሽን one-to-one መሆኑና on-to መሆኑን ቼክ ለማድረግ ምንድን ነው የምናደርገው? መጀመሪያ ዴፊኒሽኑን ማስታወስ ያስፈልጋል። A function f which defined from a to b is said to be one-to-one if f of x1 is equal to f of x2 implies x1 is equal to x2. ይሄ ሎጂካል ኢምፕሊኬሽን ሁሉ ጊዜ እውነት ከሆነ ማለት f of x1 እና f of x2 እኩል ከሆኑ ሁሉ ጊዜ x1 እና x2 እኩል ከሆነ for n x1 and x2, it is just say x2 within a in the domain of the given function, then the function is said to be one-to-one function. ነገር ግን ይሄ ፎልስ ከሆነ ያ ማለት ነው ይሄ ፎልስ የሚሆነው መቼ ነው? ይሄ f of x1 እና f of x2 እኩል መሆናቸው ትሩ ሲሆንና x1 እና x2 የተለያዩ ከሆኑ ስለዚህ ሁለት የተለያዩ የዶሜኑ ኤሌመንቶች ተመሳሳይ ኢሜጅ ኖራቸው ማለት ነው። በዚህ ጊዜ ይህ ፋንክሽን one-to-one ፋንክሽን አይባልም ወይም ደግሞ ሊሆን አይችልም ማለት ነው። ስለዚህ based on this criteria ይህን ሜጀር በምናደርግበት ጊዜ the function that is f of x equal to 6x minus 1 is linear with non-zero slope, which is strictly increasing function. That means በነገራችን ላይ ማንኛውም strictly increasing function ወይም ደግሞ strictly decreasing function ሁሉ ጊዜ one-to-one ነው። one-to-one ብቻ አይደለም, it is also an on-to function. ስለዚህ hence it is an increasing function. Therefore, the given function that simply 6x f of x equal to 6x minus 1 is both one-to-one and on-to function. It is on-to function. We have this remark. Every strictly increasing function is one-to-one function and it is also an on-to function. It is also an on-to function. Next one, that's simply b, f of x equal to x squared plus 7 is given. ስለዚህ ይሄን one-to-one እና on-to መሆኑን ቼክ ማድረግ ነው። ስለዚህ f of x ዲፋይን የተደረገው የቱ ጋር ነው? I think it is from r to r ነው። from r to r። ስለዚህ ይሄ ፋንክሽን ለምሳሌ ይሄ ፋንክሽን one-to-one አይደለም። ለምን ሲባል because ለምሳሌ if you take -2 and +2 or -1 and +1, f of -1 and f of -2 are the same, that's simply 1. ስለዚህ ይህ ሎጂካል ኢምፕሊኬሽን ፎልስ ሆነ ማለት ነው። ምክንያቱም f of 1 እና f of 2 ሁለቱ እኩል ናቸው፣ ትሩ ነው ይሄ። ነገር ግን አንድና ኔጌቲቭ 1 ሁለቱ እኩል አይደሉም፣ ይሄ ፎልስ ነው። ስለዚህ ፎልስ ኢምፕላይስ ትሩ፣ ፎልስ ሆነ። therefore this function is not one-to-one function. ፋንክሽኑ ኦንቱም አይደለም። ለምንድን ነው ኦንቱ የማይሆነው? ምክንያቱም ፋንክሽኑ ዲፋይን የተደረገው from set of real number into set of real number r to r ነው። ስለዚህ አንድ ፋንክሽን ኦንቱ ነው የሚባለው ይሄ ፋንክሽን ለምሳሌ from a into that of b ኦንቱ የሚሆነው መቼ ነው? if and only if every element of the codomain of this function, that simply b, is at and primate for at least one element within the domain of the given function. ወይም ደግሞ የዶሜኑ ወይም ደግሞ የዚህ የፋንክሽኑ ሬንጅ ከኮዶሜኑ ጋር እኩል ሲሆን ማለት ነው። ስለዚህ የዚህ ዶሜኑ ምንድነው የሚሆነው? the domain of this one ምክንያቱም ይሄ ሁሉ ጊዜ 0 ወይም ደግሞ ፖዚቲቭ ነው x greater than or equal to 7 in the domain, but the codomain is a set of real number, so that the codomain and the domain of this function are not the same, so that the function is not an onto function. because the range is 7 to positive infinity, which is different from that of the codomain of the given function that is simply R, so that the function is not one-to-one and on that it is neither of the two. It is neither. Next, question number C. We are given f of x equal to x plus 1 over x minus 7. ስለዚህ f of x1 is equal to f of x2 implies x1 is equal to x2. ይህን further simplify ማድረግ ይቻላል። This is always true for the domain of the given function, which is set of real number without 7. ስለዚህ for all x1 and x2, hence the function is one-to-one function. ኦንቱ መሆኑን ለማሳየት ግን ማለት አለብን from set of real number without 7 to r ነው ዲፋይን የተደረገው። ስለዚህ ኦንቱ የሚሆነው መቼ ነው? for any real number must be a pre-image or simply an image for at least one element within the range of, within the domain of this function, that is domain of f ሲሆን ነው። ስለዚህ ይህን ሲምፕሊፋይ በምናደርግበት ጊዜ but the function is not unknown because ለምሳሌ y is equal to x plus 1 በምንልበት ጊዜ over x minus 1 ለx solve ብናደርግ we have this one. Sorry, this must be y. This must be this y. ስለዚህ x equal to 8 over y minus 2. ስለዚህ አሁን እዚህ ጋር y ማለት the range, possible range of this function is the set of real number without 2. ነገር ግን function define የተደረገው from r to r ነው። ስለዚህ from r to r ከሆነ define የተደረገው የዚህ function range ከኮዶሜኑ ጋር የተለያየ ሆነ ወይም ደግሞ ምን ማለት ነው? within the codomain of the given function or the range of the given function 2 cannot be the image of any real number. So that in this case, the function cannot be an onto function. It is not onto. Therefore, this means that it is impossible to get a pre-image for y is equal to 2, so that the function is not onto function. It is not on function. Okay, let's continue. Next question. f of x equal to x cubed is given. Therefore, the function is strictly increasing on set of real number. So it is the node function. And ቅድም ብለናል ማንኛውም strictly increasing function onto function ነው onto one-to-one ነው። Therefore, the function is both one-to-one and it is an onto function. And the last one, that is e, f of x equal to absolute value of x is given. It is not one-to-one function. We know that the image of, for example, any two opposite numbers is the same. So that it cannot be one-to-one function. This is simple counter example. F of 2 and f of minus 2 are the same, or f of minus 1 and f of positive 1 are also the same, so that it is not one-to-one function. Function onto አይደለም ምክንያቱም the function defined from r to r, but the domain of this function, the domain set of real number, but the range is always non-negative real number. ስለዚህ ኔጌቲቮቹ ለማንኛውም ሪል ነምበር ኢሜጅ መሆን አይችሉም። ስለዚህ ይሄ ፋንክሽን ኦንቱ ፋንክሽን ሊሆን አይችልም ማለት ነው። it is not onto because negative numbers are not in the range of the given function, or negative numbers cannot be an image for any element within the set of real number, or simply within the domain of the given function. Question number 10. Find the inverse of each of the following functions. We are given about 3 functions, and we are asked just to find the formula for the inverse of the given function. Let us start from the first one, that is h of x equals to x minus 3 is given. ስለዚህ መጀመሪያው ምንድነው የምናደርገው? ፕሮሲጀሮች አሉን። let, for example, the image of x under h is y. ስለዚህ h of x equals to x minus y can be expressed as, or simply will becomes y is equal to x minus 3. ከዛ ምንድን ነው የምናደርገው? we can exchange or simply swap the variables, simply replacing x in the place of y and y in the place of x, and we can have here that is x equal to 3y minus 3። ስለዚህ ይሄ ኢኩዌዥን ከየት የመጣው? ከዚህ ነው። ምን በማድረግ ኤክስ እና ዋይን ስዋፕ በማድረግ ወይም ደግሞ ቦታቸውን በማቀያየር ከዛ በኋላ ለአዲሱ ቫሪያብል ለዋይ ሶልቭ እናደርጋለን። ሶልቭ በምናደርግበት ጊዜ ይህን ወደዚህ እንወስዳለን። it becomes x plus 3 both sides ለሶስት ስናካፍል we can have y is equal to x plus 3 over 3. So by assuming that x is an independent variable, the usual independent variable for the expression of any function, so that in this case the inverse of the given function, that is f inverse of x, I mean h inverse of x is equal to x plus 3 over 3, x plus 3 over 3. Next to be h of x given to be 2x cubed plus 3, so that the inverse of this function could be, again let h of x is y, so that we have y is equal to x cubed plus 3. ስለዚህ በቀጥታ አሁን እዚህ ጋር ቫሪያብሎቹን ሪፕሌስ ሳናደርግ ወይም ደግሞ ስዋፕ ሳናደርግ ኤክስቼንጅ ሳናደርግ ለኤክስ ሶልቭ በማድረግም ኢንቨርሱ መፈለግ ይቻላል። ለምሳሌ ለኤክስ ሶልቭ በምናደርግበት ጊዜ እዚህ ጋር both sides ሶስትን ስንቀንስ we can have y minus 3 is equal to 2x cubed። ከዛ ለኤክስ አር ሶልቭ ማድረግ የፈለግነው ለሁለት ስናካፍል we have ለሁለት ካካፈልን በኋላ ኪዩብሩትን both sides ኪዩብሩት በምንወስድበት ጊዜ x is equal to the cube root of y minus 3 over 3 ይሆናል። Therefore the inverse of this function, that is h inverse of x, could be just this one, that is the cube root of x minus 3 over 2. Okay, next question. That is question number 3. C. G of x is given to be 1 over 5x plus 2. Therefore, y could be, that is letting g of x to be y, 1 over 5x plus 2 አለን። ስለዚህ ይህንንም ለኤክስ ሶልቭ በምናደርግበት ጊዜ ሁለትን both sides ስንቀንስ we have y minus 2 is equal to 1 over 5x. And multiplying both sides of this equation by 5, we have x equal to 5 into y minus 2. Therefore, h inverse of x could be, g inverse of x could be 5x minus 10, that is distributing this one over here. We can have 5x minus 10 will be directly the inverse of this function. Okay, ሌላው እዚህ ኢንቨርስ ፋንክሽን እና ፋንክሽን ወይም ደግሞ ኢንቨርስ ላይ ማወቅ ያለብን ነገር ምንድን ነው? ለምሳሌ if g inverse of x, this one is the inverse of this function, የዚህ ፋንክሽን ዶሜን ማለት ለዚህ ለኢንቨርሱ ሬንጅ ይሆናል። የዚህ የሬንጁ ዶሜን ማለት ደግሞ ለኦሪጂናል ፋንክሽን ለጂ ኦፍ ኤክስ ዶሜን ይሆናል ማለት ነው። ሬንጅ ይሆናል ማለት ነው። ስለዚህ ዶሜን እና ሬንጅ እንደዛው ተቀያይረው የሚገኙ መሆኑን ማስታወስ ተገቢ ነው ወይም ደግሞ ጠቃሚ ነው። ኦኬ let's continue. Question number 11. We are asking just to find the range of g of x equal to 2x plus 1, f of x equal to x plus 1 over 2x minus 1, h of x equal to the square root of x plus 4 minus 3. ስለዚህ ሬንጅ ነው የተጠየቅነው። ስለዚህ ከመጀመሪያ ከጂ ኦፍ ኤክስ በምነሳበት ጊዜ g of x equal to x plus 1 is given. Therefore, the function is linear function, and it is linear, and linear functions take all real numbers or simple real values, or they are one-to-one in that of onto functions. Therefore, the range could be a set of real number. The range is set of real number, or every real number could be an image for at least one real number within the domain of the given function, that set of real number, since it is a strictly increasing or simply increasing function. B, f of x equal to x plus 1 over 2x minus 1 is given. ስለዚህ የዚህን ሬንጅ በምንፈልግበት ጊዜ the range could be, that is possible value of y ነው ወይም ደግሞ ኢሜጆቹ ማለት ነው። ስለዚህ y is equal to x plus 1 over 2x minus 1 ቢሆን ይህንን ለx ሶልቭ በምናደርግበት ጊዜ we can have this one, that is x into 2y minus 1 is equal to y plus 1, or x is equal to y plus 1 over 2y minus 1. ስለዚህ the domain of this one or the possible value of y here could be all the possible values of y could be the range of the given function. ስለዚህ 2y minus 1 non-zero መሆን አለበት and it could be non-zero whenever y is different from that of 1 over 2. Therefore, the range could be the set of real number that can, without the set containing set of real number that can make 2y minus 1 is 0. Therefore, y different from that of 1 over 2 could be the range of the given function. Okay, see, h of x equal to the square root of x plus 4 minus 3 is given. ስለዚህ ይህንን በምንወስድበት ጊዜ h of x is positive or simply greater than or equal to 0, and we have minus 3 here. Therefore, we have h of x is greater than or equal to the possible or simply the range of this one minus 3, which is greater than or equal to minus 3. Therefore, the range could be the interval from minus 3 to positive infinity. Next, use the division algorithm just to divide this one x cubed plus 2x squared minus 5x plus 6 by x squared minus 2, and the second one is apply the remainder theorem to find the remainder when f of x equal to 2x cubed minus 3x squared plus 4x minus 5 is divided by linear polynomial function of x minus 1. So let us start from the first one. Using log division methods, we have this one that is leading coefficienቶቻቸውን በምናካፍልበት ጊዜ የመጀመሪያው ተርም ለማግኘት x cubed over x squared is x. Then x cubed plus 2x squared minus 5x plus 6 minus this x multiplied by the denominator. Denominator በዚህ በኮሸንቱ አባዝተን ከዚህ ላይ ስንቀንስ ይሄን እናገኛለን. That means we have 2x squared minus 3x plus 6. Okay, ስለዚህ ይሄ ተቀንሶ ይሄን አግኝተናል. This is the first remainder which is obtained here. ከዛ በኋላ እንደገና አሁንም ይሄንን ለዚህ ለx square minus 2 በምናካፍልበት ጊዜ የዚህ ሊዲንግ ተርም ለዚህ ለታችኛው ሊዲንግ ተርም በምናካፍልበት ጊዜ2x square over x square is 2 ይሆናል። ስለዚህ 2 ከሆነ አሁን ከዚህ ከ2x square minus 3x plus 6 ላይ 2 times the denominator that is 2 times x square minus 2 መቀነስ አለበት። ስለዚህ ስንቀንስ 2x square minus 3x plus 6 minus 2 into x square minus 2 would be simplified to this one that is minus 3x plus 10. Hence, ይሁን ሪሜንደር ነው ምክንያቱም የዚህ ዲግሪ ከዲቫይደሩ ከx square minus 2 ዲግሪ ያንሳል። ስለዚህ ይሄን minus 3x plus 10 ለx square minus 2 ማካፈል አንችልም. So that this could be exactly the remainder which is obtained from the division. Minus 3x plus 10. Thus, the quotient is the terms that are obtained, the first one x, እንደገና ደግሞ አሁን ሁለትን አግኝተናል። ስለዚህ x plus 2 is the quotient polynomial function, and the remainder is this one. Therefore, hence this one, the denominator of the given fraction, that is x cubed plus 2x squared minus 5x plus 6, can be expressed as using polynomial division algorithm. That means x cubed plus 2x squared minus 5x plus 6 is equal to x plus 2, the quotient polynomial function, times the divisor that is x squared minus 2 plus the remainder which is minus 3x plus 10. Minus 3x plus 10. Therefore, this is the process. Next question, question number B. We are asked just to find the remainder when f of x, this expression, is divided by x minus 1. We have this remark, the remainder theorem about. The remainder theorem stated that when a polynomial f of x is divided by the linear polynomial function of this form that is x minus a, the remainder is always f of a. ስለዚህ ይህ ፖሊኖሚያል ፋንክሽን ለx minus 1 በሚካፈልበት ጊዜ የሚገኘውን ሪሜንደር በሪሜንደር ቴረም ለማግኘት you only substitute r. R in this case is 1. That is 1 in the place of x here. ስለዚህ r is equal to f of 1. f of 1 ማለት directly if you substitute one within 4x within the terms of f of x here, we have 2 times 1 cubed minus 3 times 1 squared plus 4 times 1 minus 5, which is equal to negative 2. Negative, so that the remainder when this polynomial function divided by x minus 1 would be this one, that is minus 2. Therefore, it is minus 2 and the remainder is minus 2. Next, that is C. We are asked just to verify whether x minus 3 is the factor of f of x is equal to x cubed minus 7x plus 6 or not, using the remainder theorem. ስለዚህ ሪሜንደር ቴረም አንድ ፖሊኖሚያል ፋንክሽን ለዚህ አይነት ፖሊኖሚያል ፋንክሽን ወይም ደግሞ ሊኒየር ፖሊኖሚያል ፋንክሽን በሚካፈልበት ጊዜ የምናገኘው ሪሜንደር it could be f of r or simply in this case f of 3 ነው። ስለዚህ x minus 3 ለዚህ ፖሊኖሚያል ፋንክሽን ፋክተር ከሆነ ደግሞ the remainder which is obtained from dividing f of x by x minus 3 must be exactly equal with 0 መሆን አለበት ፋክተር ከሆነ። ስለዚህ ፋክተሩ ደግሞ ሪሜንደሩ ዜሮ ከሆነ ፋክተር አይደለም፣ ሪሜንደሩ ዜሮ ከሆነ ግን ፋክተር ነው። ስለዚህ በቀላሉ በሪሜንደር ቴረም ሪሜንደሩን በምንፈልግበት ጊዜ let's compute the remainder using remainder theorem. We have r is equal to f of 3, which is equal to 27. That is, if you substitute 3 directly in the place of x here, minus 21 plus 6, which is 12. So that which is non-zero. Since r is equal to f of 3, which is different from that of 0, so that x minus 3 is not the factor of f of x. It is not the factor. Okay, thank you. That is all what I have for